Good evening, MBA 510 students. This is just, this week we're actually going to do a module 4, and that's relevant costing. That's mainly a reading chapter, and the exercise I've assigned are just so you understand the concepts in that particular chapter, and it has to do with decision making. And I think if you had even microeconomics, it's pretty basic stuff. So basically, with respect to that chapter, it'll be a reading chapter, and then if you want help, I'll give you help. But at the same time, it my business course exercise will be the main thing. One thing I do want to do is sort of in this week, though, is bring together the last two chapters. One was in cost behavior, and the other one was cost volume profit. I'm just going to do this by requiring you to do a short, sort of, I would call it reinforcement exercise on Excel, where I want you to relate the regression we did with cost volume profit. At least start thinking in those terms. And I think almost not every week, but many times during this, at least 2 or 3 more times during this summer, I'm going to do more exercise on this because it's very important. It's very applicable to business. Okay, so there's going to be 2 videos here. The first time I'm going to sort of go back over how to do the parameters of a regression line and a scatter graph. And I'm going to tie that in with the cost volume profit. The first thing was module 1, and then I'm going to tie that in with module 3, which was cost volume profit. So I want you to tie these things together and start thinking about how you would use these in business. Maybe we'll have a short case study on this as the class goes on, because these are very important concepts, and you should know how to use a little bit of Excel here. Okay, so let's go to the first video will be we're just going to construct a scatter graph, and then we're going to actually place a regression line in the scatter graph. Okay, now let's do this. First of all, what I'm going to do is I'm going to insert here a row, and I'll be sending you this. I'm going to put a regression line. And let's recall that in this, what we're trying to do is we're going to take total costs of any product that you're making in a factory. Let's say total fixed costs plus variable costs per unit times the number of units. And I'm just going to put units here. Okay. And so this is the line that we're going for. Okay, and remember that the most scientific way of doing this, I'm assuming you may have had some stats, the quote-unquote most scientific way of doing this is by constructing a regression line, which uses kind of method which tries to minimize, but place a line through a scatter graph, which minimizes the vertical distance between the lines and the various points. Those are called the residuals. That's what we built last time. Okay, so if you recall, the way to get the intercept of the line when it crosses the x-axis, the cost axis, is we use the function is equal to intercept. So we're going to just go intercept. And by the way, we're going to be using this data here. We're going to be using this data right here. Okay, so we're just going to use the function intercept. And go ahead and click on that. It asks for known y's and known x's. Our known y's is this right here. And we'll actually just put the numbers in. And so our known y's are the total costs. Okay? And this is an example of a table manufacturer. So total manufacturing cost to make tables for each one of these periods are those monetary amounts there. And then the number of tables produced will be the amount right there. Okay, so our intercept should be 20,000. I'm going to change this too. So our total fixed costs are equal to, I'm going to format these cells so they're dollars. Excuse me. There it is. Okay, so our total fixed costs are going to be, we're going to put them in dollars here. $20,866 total fixed costs. Okay, now, so that's where and we'll actually do this in a second. That's where the line is going to go down and cross the x-axis, the cost axis. Remember that it crosses the axis where there's 0 units produced, but even where you have 0 units produced, you can have a certain level of fixed costs. Okay, and now let's do the variable cost per unit. The variable cost per unit will be, we'll use the slope function. So we'll use the slope function. It's the slope of a line. And once again, you have known y's and known x's. Known y's, which is your independent variable, and your x's, which is your dependent variable. Excuse me, your known y's, which are your dependent variable, and your known x's, which is your independent variable. In this case, the number of tables you make your independent variable, and the number and the dependent variable is the total cost. Okay, so let's see what we get here. We get variable cost per unit of $158, and I'm just going to go ahead and format this to in dollars. It's very important. Okay, so we will format this in terms of dollars. That looks good to me. Okay, so we have here a regression line. The regression line is of this form here, of this form right here. Okay, and we'll be more specific about it. Your total cost, and I'm going to split this up. Total cost is equal to total fixed cost times number of units. So the only thing you're going to have to do when we get, if you wanted to predict cost, it would be predict the number of units. Okay, so your total fixed cost times the number of units. What we're getting here is your total cost line that you got by using regression was, in this case, total cost, and I say total cost is equal to total fixed cost, which is equal to $20,886.41. That's your basic cost plus your variable cost per unit, which is $158.65 per unit. That's going to be times whatever number of units you want to fill in. This is a prediction line based on the data that we just put in to the regression line. This is going to be the data that you put in. You can put in any number of units you want. So that's the output. And like I said in 2 chapters ago, this is what the output you're looking for. Well, let's go ahead and make a scatter graph, because the chapter module 2 is really big on scatter graphs. So let's go ahead and make a scatter graph, and we'll even let's do this. Notice that the lowest level here, there's nothing that goes, there's no lower level in terms of the units than about 300. 293 is your lowest, I think. 248, 250 is your lowest. So I will put in a row here, and just so that I can have, I'm going to go ahead and make a line. I'm going to go ahead and make a scatter graph and then make a trend line. I want the trend line to actually cross the x-axis. So what I'm saying, what the regression line is telling us, is that when the number of tables is 0, so when the units produced is 0, our fixed costs, our costs are going to be equal to that. So that's your minimum cost right there. Okay, so what I'm going to try to do now is go ahead and highlight these right here, and we'll make a scatter graph, and we'll try to put a trend line in there. The trend line, basically, that is the regression line, and to see how the line fits amongst all these points. So we're going to go ahead and go up here to insert. You hit the recommended chart right there, and this looks like a pretty good chart right here. That is a scatter graph, and one thing I want you to notice is that most of the points are at the top, but there is one point which is your fixed cost, and there you see right there. That's the point of at a point of 0 units of production. your fixed cost, your basic line is equal to $20,886. Okay, so what we're going to do here is we're going to add a trend line to this, and it's linear. You want it to be linear. There it is right there. There's your trend line, and that's basically a regression line. And notice that most of the points were 250 and beyond. I put in that extra point so you could see where the fixed costs are. So those are your total cost line right there. That's your total cost line using a scatter graph in Excel. And I'm probably going to have you do this. I'll just give you the day and have you do this. It looks pretty good because you'll notice that the points, the line pretty much, there's not a lot of vertical distance. Those so-called residuals are the vertical distance and the point on the line for the same level of production. So even some of the highest units here, some of the highest units seem to almost be on the line. So you have a lot, 3 or 4 points. You have 5 or 6 points which are almost on the line, and the others aren't too far from the line. So you don't have any one point that's throwing the line off. And then I put this low point in here, and let's see if we get that because that's your fixed cost right here. Okay, and then finally, let's go ahead, and it looks like you should get a pretty high R square. Remember that R square, the higher the R square, it's a percentage between 0 and 1, which is between 0% and 100%. And the higher the R square, the better the fit of the line. So when you have a high R square, you should have a line which doesn't have a lot of high levels of residuals, vertical distances between the line and the actual points that were observed. Okay, so I guess this is R equal to, I think the function is R square, that's it right there. Okay, and once again, we put in our known y's, and I'm just going to start without the point that I fit in there myself. And then known x's, let's see what we got here. Should give you a pretty decent R square. Well, that's not bad. It means that 68% of the variation in total costs can be explained by the number of tables you make. I mean, there could be other things, the weather, if you're up north and it's cold and you have to run the heat all the time, that'll affect it. Things like that. There's a lot of, but basically table seems to be a good predictor. And you might want to, the number of tables you make, explain the total cost, manufacturing costs, and you might want to add other variables. Anyway, so that's the first video. In the next video, I'm actually going to come over here and use the numbers that I got here. All I'm going to do is fit them into into this example here on cost, volume, profit. Well, what I'm trying to do here is at least reinforce the concepts of how to make a total cost line using regression, and how that fits into cost, volume, profit. So you can start thinking about how to use these tools on your own. Anyway, I will cut this one off. I'm trying to keep these videos short, and then I will start the next video. 13 minutes, not bad.